A gas mixture with a total pressure of 300 torr consists of equal masses of neon and argon. The partial pressure of argon is, and we have to choose. Okay? Now, this partial pressure problem presumes that you remember that the total pressure is the sum of the partial pressures of the two gases. And in particular, the partial pressure of argon will be given by the product of the mole fraction of argon in the mixture times the total pressure. Remember that? So the hard part of the question boils down to how can I translate this statement, equal masses of neon and argon, into a value for the mole fraction? Yes? Yeah, you can assume, the trick is you have to assume some mass. But it doesn't matter what mass you assume. You can assume any mass that you want and just follow through and calculate the number of moles because the mole fraction is a ratio. So it does not matter. So let's assume, I think I assumed 10 grams. 10 grams of each gas. It doesn't matter how much, just so you're consistent about this. 10 grams of neon times 1 mole of neon. I'm going to do a mass to mole conversion here. It's 20.2 grams of neon per mole, and that gave me 0.496 moles of neon. Okay, if I do the same thing with 10 grams of argon, one mole of argon over, that's 40 grams of argon, I get 0.250 moles of argon. Okay, regular mass to mole, nothing real special there. The total moles would be 6, 14, 7, 746 moles total. So chi of argon, the mole fraction of argon, would be equal to 0.250 moles of argon over total moles 0.746, and I got 0.336. Now remember, mole fractions have no units because they're ratios. Okay? So now the partial pressure of argon, according to this equation up here, is simply 0.336 times the P total, which is 300 torr. And this turned out to be 100 torr. That was the closest answer.